So as Rory mentioned, I'm a writer now. Rory handled my introduction for me, thank you. Not a scientist anymore. I did used to work in computational neuroscience labs. So while I'm not an expert on any of the math you all know, I don't even understand most of the math you all know. I understand what sorts of problems you all know how to solve with your tools. And so what I hope to do today is sort of pitch to you a phenomenon that I wonder if some of you might take an interest in trying to study. I am a writer. Writers always tell other writers, show, don't tell. Right? If any of you have ever tried writing for the public, that's what they always tell you to do. So I'm going to show you something. These are the notes I took at 4:30 this morning when I woke up at about that time, right? They're tiny little spidery notes, right? They scribble up the page, and I can't even read them, right? This is about the 20th version of an intro that I have written in the last 2 weeks, and none of them did I ever reread or memorize, obviously. But this is very typical of something called graphomania, right? This compulsion, this like compulsive drive to just pour words onto paper, and this feeling, it feels totally involuntary, like like you've just inhaled some kind of genie or spirit, and it's just like the ideas are just racing out of you. And that doesn't mean it doesn't mean that you're a genius, right? Most of the ideas are chaotic and a mess. However, right, it's also what we sometimes call divergent cognition. You may have heard this term before, right? It's a measure people sometimes use for measuring creativity, right? And it's basically this capacity for finding connections between seemingly unlike things. And this type of racing mind very clearly produces both, right? It can produce a total disorganized chaos that lands people in hospitals. It landed me in a hospital 10 years ago. But it also absolutely produces a kind of thought that can be very productive and helpful. And so what I want to talk to you about today is not a morbid disease, but a state that we're all familiar with, that we've all experienced at some point in our life. It's motivation, basically, or what we heard a talk earlier on boredom, and Rory brought up the flow state, as people tend to call it, right? That's the closest thing I think every one of you as academics has definitely experienced to what mania or something like mania is like, right? Where work feels completely effortless, and you feel absolutely no need for sleep, as I have not felt recently. You may notice I shake a lot. I might be pacing. These are sort of classic, typical behavioral features of not the kind of mania you need to go to the hospital for, but sort of manium spectrum behavior. So you may or may not be aware that it is possible now to grow in a dish the neuron of somebody who is alive. Right? So you could take, I'll explain more in a moment. Basically, technology is called induced pluripotent stem cells. You can take a somatic cell, a skin cell from somebody like me, somebody like Rory, let's say, grow the two in a dish, and then you can examine the differences. If one of the persons has a particular irritable condition like bipolar disorder, you can also see what happens when you treat them with a drug. So the reason bipolar is a particularly compelling model, I think, for studying motivation and drive is that not only is it an episodic condition where the sort of degree of the pathology waxes and wanes across time, just like sort of inspiration waxes and wanes in all of us, but also it responds to a drug, right? You're probably aware, in 200 years, psychiatry has basically produced 0 effective drugs. I mean, flip of a coin. You go to take an antidepressant, flip of a coin if it's going to work for you, right? It's all trial and error. Same with antipsychotics. No biomarkers, right? There's no change in a brain scan or a gene or a blood sample that can tell you what sickness someone has and what drug they're going to respond to. In fact, the only pathognomic, as they call it, disease naming sign in all of psychiatry is response to lithium, right? So too late. we needed to know before this, right? And why is that? Because lithium is pretty much the only drug that does what lithium does, which is to say it takes an illness that would literally have people like me living in mental hospitals, right, before 1949, and makes them able to live a full life, right? But does it cure you? Absolutely not, right? Look at me. Obviously, I'm not cured, right? Don't want to be, shouldn't want to be. So, whoops, how does this work?
Because I'm like all the way right.
You move the mouse to the screen.
And then you go down and click.
Thank you, sorry. Oh, shoot, it was a little slow, so it doesn't disappear. Okay, over 100 years ago, William James wrote this famous book, Varieties of Religious Experience. I avoided reading it for a long time because it had religious in the title, and I didn't think I was interested in religion. But his book isn't really about religion. What it's actually about is what he calls the reality of the unseen. That means elements of subjective experience that are not easily observable or quantifiable, but are nonetheless vital to understanding the way the mind works. I love this quote. It's sort of one motivation for my work. James says, insane conditions have this advantage, that they isolate special factors of the mental life. They play the part in mental anatomy which the scalpel and the microscope play in the anatomy of the body. To understand a thing rightly, we need to have acquaintance with the whole range of its variations. In other words, what is something like bipolar? Not a binary illness, not something to be studied by clinical people alone, to be abandoned to the clinical people, to be abandoned to the pharmacology, something to be studied by people like you who study basic science and want to understand the basic workings of the brain and the mind. We're an outlier, right? And an outlier can be useful. Okay. Right, so you can't quite read it. Friedrich Nietzsche, also about 100 years ago. I mentioned them both because they're two pioneers who both emphasized a long time ago that we can't understand thinking without understanding drive, or without understanding motivation. Nietzsche said the only seeing we have is seeing with perspective. And what he meant was not only that sort of each individual has their own separate set of values, but that these values are always in flux. And so what I'm showing a set of model organisms, as it were, up here. On the right, you see the Hydra. The Hydra was discovered by Leeuwenhoek way back in the 1700s. And it's been used as a model for studying regeneration and embryonic development and so forth in the past. More recently, every neuron in its body was visualized using calcium imaging in real time. And that was the first time that had been done in any organism as a Hydra. The star-nosed mole similarly has these 22 fingers on its face, right, that have incredible sense of touch, right? So it's been deeply studied in order to understand the sense of touch. What I'd like to suggest to you today is that people like Virginia Woolf and Kanye West, who you might think have nothing in common, but they do. They were both manic depressive, or are both manic depressive. These two are model organisms too. Right? Just as you can use the star-nosed mole to better understand touch, use these type of people to better understand drive, right? Motivation, and the shifts in drive. So the view from the cell perspective, the image you see on the left here was the backdrop of my desktop for years. It's an image of a neuron from a bipolar person, lithium-responsive bipolar person. I should be clear. Lithium responsive, bipolar 1. Bipolar disorder, if you've ever heard the term, you all heard the term, but it encompasses a vast heterogeneous mix of people. Only a third of people respond to lithium. This suggests, of course, that they don't have the same condition that the other 2/3 do. And it's also what makes lithium responsive bipolar 1 so precious, right? It's this one sort of nosological category where we actually have a well-characterized condition and a drug that acts on some mechanism that's still unknown, but acts on one effectively. So in 2015, Mertens et al. Published this paper. It was the first using induced pluripotent stem cells to grow neurons from bipolar people in a dish. And what they showed was, I'll explain in a minute the details, but they showed differences at the cellular level in people with bipolar, whether they had bipolar lithium responsive or non-lithium responsive bipolar. And they showed at the level of the cell metabolic changes that happened in response to lithium. This is really exciting because what we know at the level of the human is that lithium is affecting a person's personality and mind and behavior in these radically sort of phenomenological ways. And so what I'm wondering is if it might be possible to make a linkage between this sort of high-level cognitive experience and what happens at the cellular level. Okay, so this is the closest thing to math you're going to see here. I drew it by hand so that no one would confuse it for real data or me for an actual scientist. But I think many of you are going to see, we heard it talk about manifolds, right? I don't even know what that means. I'd never heard that word before, but I was familiar. I knew the kinds of things, I knew the sorts of problem that things like principal components analysis and factor analysis can solve. And so I thought for you all, I'd try to speak in your language. So this box contains everything we can think or feel, right? And every dot you're about to see, you can think of as a mental state. You guys are accustomed to thinking like this, right? So proximity equals similarity, and you might imagine like, so this might be the day you meet the love of your life, and this might be this great conference in Greece that you're going to go to that's extremely exciting, but also kind of intimidating because you're going to talk to a bunch of scientists and been in science in years. I teach like actual children. 8-year-olds, 9, 10. Yeah, that's fair. So right, so my point being that I think this is an excitability. Like this represents excitability, not necessarily a positive feeling, but just right. And at the other end of the spectrum, in purple, that's like a deep meditative state, right, where someone has actually has escaped the suffering desire brains. Right? I can't imagine that, but some people achieve that. Okay, so that's one way of thinking about space. Another way of thinking is that each of the dots is a person, and they're sitting in the space that's sort of the part of the space that's sort of average for them, and you might call the red dots the bipolar people. Now, if you think about it like that, and think who are the orange dots? They're the first degree relatives, right? So, for example, my sister, she doesn't have bipolar. She's run 7 marathons. She's a pediatrician married to a surgeon. She talks extremely fast. She's a very motivated and driven person, right? We have a history of bipolar in my family. When I first was prescribed antidepressant drugs around that time, my grandfather's brother shot himself. He'd gone to Yale. He'd run a business for many years. His grandfather before him had 100 patents back in the early 20th century for technologies related to electromagnets. Before around my age, he was checked into a fancy sanitarium and he took an overdose of pills and killed himself. The point being that, yeah, those two were not oranges, those were reds, right? But my family's fully, there was a Rhodes Scholar a couple generations ago, and loads of people have gone to colleges and gone on to become doctors and lawyers and stuff. And I don't say this, obviously, to brag about a pedigree, but what I did point it out to say that what we're really studying here is personality traits that run in families, not a disease per se, right? Another example, Teddy Roosevelt. He didn't have bipolar, but his mother did, and so did his brother. Who was his brother's daughter? Eleanor Roosevelt, one of the most influential women in American political history. So again, there are countless anecdotal examples, but it's just to point out that I think just as James said about varieties, we need to be thinking not in terms of disease classes, but rather in terms of continuous variation in traits. Oh yeah, so I came up with these 3 ideas. I don't mean to suggest that these 3 types of factors are actually orthogonal. I actually don't think they're orthogonal at all, right? But in general, you have these metabolic factors that are coming out of the cellular research, that behavioral factors we'll look at in a second, and these perceptual ones are the ones I'm most interested in, the ones that are most in kind of unreachable without a special way in. So here's the details about what people found in those early studies on bipolar cells in addition. For one thing, the neuron from somebody with bipolar pretty much acts like a person. It's hyperexcitable. You stimulate it just a little, and you stimulate it just a little, and it starts firing action potentials quick. But when you drop lithium on it, if the person is lithium responsive, it slows down. It doesn't normalize. It's still faster than normal, but it mitigates it. One of the most exciting findings is that the mitochondria themselves were dysfunctional. And that's a pretty vague word, and that's because they haven't quite sorted out everything to do with that. There was a big paper just a week ago that I didn't have a chance to read that listed a whole bunch of mitochondrial changes. Some of them had to do with gene expression and so forth and so on. But obviously, because bipolar is a disorder that relates to energy, it's significant that the mitochondria are somehow inefficiently or incorrectly processing glucose and producing ATP. And finally, there were like 1,000 genes that are upregulated and some 300 genes that are downregulated. And amazingly, this ion somehow normalizes this. Doesn't normalize it all the way, but it reins it in. And the most important thing, if you've known anybody with bipolar, all of you have now, but I don't know if you have in the past, the main thing you would notice about them is that their circadian rhythms are messed up. They don't sleep like normal vampires. And so it makes sense, it made sense when people looked at individual cells in a dish that they saw, what you're looking at here is PER2, which is a period gene protein, the protein produced by a period gene, which is a clock gene that basically regulates the circadian rhythm. And it's glowing because it's attached to luciferase. And what you can see is that even at the single cell level, the bipolar person's neuron basically cycles out of phase with a normal neuron. Now, what sorts of behavioral and perceptual factors do I have in mind that might be mapped onto these very, very basal features? A major one is irritability. Irritability is probably like the chief trait related to bipolar disorder. If you guys have like a stereotype about a bipolar person, you probably think they're a hothead and their moods are really swervy. People's idea about a swervy mood, it comes more from the atypical forms of bipolar that don't respond to lithium. However, yes, we are irritable. Yes, you can. I might seem like a nice guy, but pushed, I can snap like anybody else. And a friend of mine, Nir Eshel, recently published a paper. He's a psychiatrist at Stanford. He recently published a paper showing, arguing that irritability needs to be studied more as a transdiagnostic factor across many disorders, from bipolar to ADHD to dementia. And he even pointed out that back in the 60s, a pigeon model of irritability was developed. They call it frustrated non-reward. Basically, you give a pigeon, you train a pigeon to press a button for a reward, and then you quit giving it a reward. And eventually, not only does it start pounding the key a lot, but it also starts like messing up the cage and even attacking other pigeons, right? Now, I love this. I love this when I saw Nir's paper. But I did think to myself that framing it as irritability as a symptom, as just a negative, right, might be a little bit short-sighted. I mean, so as Kanye says, this is one of my favorite Kanye quotes, Kanye says, "Everything I'm not made me everything I am," right? In other words, most of the traits that can be viewed as symptomatic in bipolar are also adaptive, assets in another context. I thought the word I would use most of the time for what best describes me is restless. I am an extremely restless person. Does that mean I'm about to snap all the time? No, but it does mean that I'm very easily bored and I need to constantly be stimulated. And so I think if we view traits like this more along a continuum, right? In the red, you've got impulsive rage, and down in the blue, you've got apathy. That's not a good thing either, right? To basically be complacent. And then somewhere in the middle, you've got what you could call motivated kind of drive that's good, and this type of divergent thinking that's making connections. I won't stay too long on this slide, but just to point out, in case you were thinking that tracking the way people think would be a hard thing to do, it's not that hard with bipolar people because when we're manic, we communicate so much. So there's actually a group at Michigan that has been building machine learning algorithms to tell, based on the pitch and the rate and the volume of a person's speech, when they might be moving into a manic episode. And essentially this kind of pressured speech, I'm doing a little bit of it right now, is totally typical of mania, along with graphomania, this urge to write. And it's not just about a volume of writing, but a type of writing, right? This divergent type of writing, this divergent type of speech. Again, if you have any close bipolar friends or family, you know when something's up with them because you get a whole bunch of texts about lots of different things in a really short span of time, right? Very enthusiastic. Okay, this is just a long list of other parameters I've come up with that we might be able to track. We talked about impulsivity a little bit, speed of processing. And again, the idea, and I don't know exactly how, but the idea is if you were able to collect loads of these sorts of parameters related to cognition, might we be able to correlate these with changes that we're seeing at the level of the cell? Finally, I mentioned earlier how lithium affects the circadian rhythm. So this was an earlier study that was actually done in mice. But what you can see is that in bipolar, ordinarily, the amplitude of the circadian rhythm, like the behavioral circadian rhythm, as well as the circadian rhythm in the cell, is lower. And the period is shorter. And what lithium basically does is to raise the amplitude and spread out the period. And they saw that this happened in the suprachiasmatic nucleus of the hypothalamus, as well as in lung tissue and in fibroblasts. Their point here was just to show that the central clock as well as the peripheral clocks were all affected. Okay, now this was one of the most exciting findings to me when I first heard about it. There's exactly one mutation for bipolar that I know I carry. You can imagine when I found out I could get sequenced by 23andMe, I was really eager to find mutations related to bipolar. I made a giant list of 64 different mutations, and I went looking. You can actually, basically, you can get all your raw data, and you can go looking for what variant you have in all these different specific locations. Unfortunately, they don't sequence the whole genome, so I couldn't find most of them. But the one I did find is this gene for a calcium channel. And it's called CACNA1C. Basically, it makes sense that a calcium channel would be deformed, of course, because if a calcium channel is misshapen, what you might get is basically a leaky channel that has too much positive charge flowing in, and it's going to make a neuron hyperexcitable. What this later paper showed is that not only is this variant predictive of having bipolar, but it's predictive of being lithium responsive. Now, that's interesting enough because this would sort of be the holy grail if we had a biomarker for lithium responsiveness. And obviously this paper, it was the 2016 paper that I'm talking about here. Obviously, it came out several years ago. We're not yet using this to diagnose people with bipolar. I'm sure that's not possible yet. But it is a flicker of a hope. Even the reason it made me even more excited, though, I'll skip this one. I'll maybe come back to this in a second. Whoops, skip this one. The reason it made me even more excited is that a lot of work has gone into characterizing lithium responders, what are called excellent lithium responders, people who, like me, will take it and not have another episode for a decade or more. And what psychologists have found is that there's actually a temperament, they call it hyperthymic, that characterizes people that respond to lithium. The main thing it means is that people who have a temperament, a sort of stable, healthy temperament that's depressive or anxious, usually won't respond to lithium. The type who will, my friends will recognize it here. Extreme talkativeness, tendency to repeat oneself, short sleeping, intolerance of boredom, expansiveness, tirelessness. I like this one because it sounds kind of nice. Irrepressibility, irresistible, an infectious quality, overconfident, warm, high energy level and productivity, overoptimistic, etc. Right? These are the people that will respond to lithium, right? These blabbermouth happy people, okay, who only quit being happy when they get manic, deplete themselves entirely and crash, right? That's what bipolar depression is for people with lithium responsive bipolar. Last slide here, just a little thought. So on the last slide, you saw this painting here is by William Blake, right? William Blake has this notion of twofold vision. What he means is that at any given moment, right, we're seeing what's coming from the world, but we're also projecting onto the world, our expectations and our hopes and our desires and so forth, and the degree to which we are seeing in twofold vision ebbs and flows over time, right? How much subjectivity we're projecting onto the world. Another painting of Blake's is one he made of Isaac Newton. He lived at the same time as Newton. And I just love this painting. Newton's sitting on the bottom of the sea, serene, right? And on the one hand, it looks like he's solving a problem, right? You know, it's not like William Blake doesn't respect science or respect calculus or math. He realizes that reductionism is helpful because it's the way you take a complex problem and you make it solvable. But the reason he puts Newton on the bottom of the sea is because reductionism is also dangerous, right? If we get too attached to a model, we don't think of conceiving of another, right? So what I mean most when I mention a model at the bottom of the sea is the conception that clinical illness is not the stuff for computational neuroscience to study. That rather clinical populations are in this sort of separate bin to be studied by doctors and psychologists. I think on the contrary, that if we really want to understand cognition, we need to understand motivation and drive, and that there's no better sort of model system than the sort of knockout mice of bipolar people. So I hope maybe I've stirred some of you to think, and I would really love to hear back from anybody about any ideas you've got on how you can apply the kind of tools you guys use to these kinds of problems. Thank you very much, guys.
That was a wonderful talk. We're probably running too late for any questions, but I think the performance itself was worth running over for. So we can talk to Taylor offline, and thank you so much for showing us that and prompting us, as we need, to thinking about these spectrums of abilities.
Thank you very much.